All right, we're going to go through the exam in this video, and I'm going to go over the ways to set up and solve the questions in this test. So starting with number 1, we look at what we're trying to solve for here. We're trying to find x, which is an angle. We're not going to use Pythagorean theorem. That would get us the other side. So we need to use trig to be able to do that. So we know the 6 is opposite, the 11 is the hypotenuse. Opposite and hypotenuse means we're going to use sine. So we set up the trig equation, sine of x is the angle we're trying to find, equal to opposite over hypotenuse, 6 over 11. To get x by itself, we have to do the inverse sine of both sides. When we do that, x will be by itself, but we have to take the inverse sine of 6 over 11. When we do that in our calculator, and we make sure our calculator's in degrees, we get 33 degrees to the nearest degree. On number 2, what a lot of people missed on this one was misdrawing the diagram. So I kind of have an illustration here of what this would look like. We have a ship, and the sonar is detecting this shipwreck on the bottom of the ocean. The angle of depression to the shipwreck is 13.2 degrees. The angle of depression is from that horizon line, or from the surface of the water down to the shipwreck. Below the boat, directly below the ship, is that 75-meter distance. We want to know how many meters the boat is from the wreck. So the point on the ocean floor is here, and we want to know its distance to the shipwreck. So to do that, we have our angle here, but that is not only our angle of depression, it's also our angle of elevation. Use that angle of elevation in the triangle here to solve for x. So from the 13.2 degrees here, 75 is opposite and the x is adjacent. Therefore, we're going to be using tangent. So tan of our angle equals opposite over adjacent. From there, we would multiply by x and divide by tan of 13.2, and we get 319.8 meters. In number 3 and number 4, we're using our 45, 45, 90 and 30, 60, 90 patterns to solve. In number 3, we have a 45, 45, 90, where the pattern is x, x, x root 2. We're given the side across from the 45, which is 3 root 6, so that will be both of the legs. And then we need to find the 90. To do that, we're going to take that x value, our 3 root 6, and multiply it times root 2. So 3 root 6 times root 2 becomes 3 root 12. But the square root of 12 can be simplified. So we break up the 12 into 4 times 3 and take out the square root of 4, and that gets multiplied by the 3 that's outside, that's the coefficient. So it becomes 6 root 3. Here we're given the hypotenuse is 10 root 2. So we have 10 root 2 is equal to our x root 2 side. So we need to divide out root 2. And what happens is the root 2's will reduce away, and we're left with x equal to 10. In number 4, we have a 30, 60, 90. It says angle D is 60 degrees. And AD is 4. The 4 is across from our 90, which gives us our 2x piece of our pattern. So if 2x is 4, we divide by 2 to get x. 2x is equal to 4, so x has to be equal to 2. Then we take x and plug it into x to get our x root 3 piece. So that becomes 2 root 3. AF is the segment we want, which is across from the 60. Therefore, AF is 2 root 3. In number 6, we're trying to find the side of the triangle labeled with x. We don't have enough to use Pythagorean theorem, so we have to use trig. We know that the 9.2 is adjacent to the 18 degrees and the h is our hypotenuse. Therefore, we know we're going to use cosine. So we have cosine of our angle equals adjacent over hypotenuse. When x is in the denominator, we have to multiply by it first. Then we have x times cos of 18 equals 9.2. To get x by itself from here, we have to divide out cosine of 18. When we do that, the cosine of 18 will reduce out on the left, and we're left with 9.2 divided by cos 18. That's what goes in our calculator. And so we get x is approximately 9.7. On number 7, we have a plane flying at an altitude of 10,000 feet. So we have a plane in the sky. It's flying towards the runway. It begins its descent 50,000 feet from a point on the ground directly below the plane. So directly below the plane in its distance to the runway is that 50,000. It's flying at an altitude of 10,000. We want to know the angle of descent or angle of depression. That's going to be this angle here. Because the angle of elevation is also congruent to the angle of depression, we can solve for it inside this triangle. So we have opposite over adjacent, so we're going to be using tangent. So tan of x equals opposite over adjacent. To get x by itself, we have to undo that tangent function. To do that, we have to take the inverse tangent of both sides. On the left, the tangent and inverse tangent will cancel away, but I then have to take the inverse tangent of 10,000 over 50,000, and I should get to the nearest degree 11 degrees. On number 8, we have the altitude of an equilateral triangle is 12. So I have an equilateral triangle that I've drawn the altitude of, and I've labeled it as 12. Find the perimeter of the equilateral triangle. We know that in an equilateral triangle, when the altitude is drawn, it creates two 30, 60, 90 triangles. Across from the 60 is that altitude. So we know our altitude, or our x root 3 piece, is 12. To get x from that, we have to divide out root 3. So we'll end up having to rationalize that denominator and get 4 root 3. That's going to be this half of the base of this triangle. To get 2x, we have 8 root 3. That's going to be this hypotenuse, or one of the sides of the equilateral triangle. If we know one of the sides is 8 root 3, it's equilateral, so we'll have 3 of those measures. So 3 times 8 root 3 will give us a perimeter of 24 root 3 units. In number 9, we have a boat that's 2,000 meters from a cliff. The angle of depression is 10. Again, that angle of depression comes from that horizontal. It's not inside the triangle here. We want to know how tall the cliff is. From the angle of depression, the angle of elevation is an alternate interior angle with it, so it's congruent. So if the angle of depression is 10 degrees, the angle of elevation is 10 degrees. From the 10, the x is opposite, the 2,000 is adjacent, and so we're using tangent to solve for x. Tangent of our angle equals opposite over adjacent. When x is in the numerator, we just multiply by our denominator. So 2,000 times tan of 10 degrees is equal to our x, which is approximately 352.7 meters to the nearest tenth. In number 10, we have a triangular base that we're trying to make out of a single length of wood. So we have 24 inches of wood that's going to be cut into 3 pieces. We want to make sure these 3 pieces make an isosceles triangle, and we want to make sure they will make a triangle. We know to do that, the 2 shorter sides have to add to be greater than the third. We want to know which of these following lengths could not be used. So let's look at the possibilities. If we're using 4 inches, either the 4 is repeated to be the isosceles legs, or it's the base of the isosceles triangle. So we have 2 possibilities there. either 4, 4, and 16, or 4, 10, and 10. Notice though that 4 plus 4 is not greater than 16, so this scenario would not make a triangle. However, the 4, 10, and 10 would. So 4 could be a length that could be used with 10 and 10 inches. What about 10? Well, we've already covered one of those scenarios with the 4, 10, and 10, which we know is possible. And the other possibility is 10, 7, and 7. Those three would add up to 24. And 7 plus 7 is 14, which is bigger than 10. For 6 inches, we have two possibilities. We would have 6 inches, and 12 inches. That adds up to 24. However, notice 6 plus 6 is not bigger than 12. So these would not make a triangle. If we used the 6 as the base of the isosceles triangle, our legs would be 9 and 9. So 6 plus 9 is 15. 15 is bigger than 9. So 6 could be used in this scenario. So we come to 12 inches. Well, we've already covered the 6, 6, and 12 scenario. Those would not make a triangle. So we know that scenario won't work. The only other scenario with 12 is if 12 is the repeated leg. So 12 and 12 would be the legs, but then there wouldn't be any piece of the wood left for the other side. So 12 is not a possible length for the triangular jewelry stand. On number 11, we want to find x. We do that by starting with this triangle with Pythagorean theorem and working our way to that 12.5 here. So starting with this first triangle on the left, we have 8 squared plus x squared equals 17 squared. And solving Pythagorean theorem, we get that x is 15. For the next triangle, we're going to use the 15 as the hypotenuse, and we're missing the other leg. So we have 9 squared plus x squared equals 15 squared. Solving Pythagorean theorem for that triangle, and we get that that missing piece is 12. Now we're going to use the 12 and the 3.5 as the legs for this final right triangle. So we have 3.5 squared plus 12 squared. Solving Pythagorean theorem for this one, and we get 12.5. So our final answer is 12.5. For number 12, we have a triangle made from the lengths 48, 55, and 73. We want to know what type of triangle that will be. So we have to use Pythagorean theorem to do that. We compare a squared plus b squared to c squared. 48 squared is 2,304, 55 squared is 3,025, and we're comparing that to 5329, which is 73 squared. When we add 2304 and 3025, we get the same value. Because those values are equal, it's a right triangle. In number 13, we're solving a 30, 60, 90 problem where we're given the 60 that's 15. In order to get x, we have to divide by root 3. So 15 divided by root 3 would be our x, but we can't leave it that way, so you have to rationalize and get 5 root 3 as your 30, and then multiply our coefficient by 2 to get 10 root 3 for the hypotenuse. In this example, you have to use both a 45, 45, 90 and a 30, 60, 90. In this first triangle here, we have a 45, 45, 90. We have a rectangle in the middle where we know this side here will be the same as this side here. So if we can solve for the leg of that 45, 45, 90, it will be a leg for the 30, 60, 90 as well. So given a hypotenuse of 10, we divide by root 2 and rationalize that denominator to get 5 root 2. So 5 root 2 are both of these legs, which makes it this leg of the 30, 60, 90. So 5 root 2 is the x root 3 part of our pattern. To be able to get x, we have to divide by root 3. So 5 root 2 divided by root 3, but we have to rationalize. So we have to multiply by root 3 over root 3, and that becomes 5 root 6 over 3. This piece is the x part of our pattern, which is what we're trying to find here, the one across from the 30 degrees. So 5 root 6 over 3 is our answer. On number 15, we're using trig to solve for x. So we have opposite over hypotenuse. So we have sine of 42 degrees equals opposite over hypotenuse. To solve for x, we're going to multiply by 12 on both sides, and that's what goes in our calculator. 12 times sine 42 is going to give us approximately 8.03, so our answer is A.